The Detomaso Mangusta arrived in 1967 with a mission to be the spiritual successor to the legendary Shelby Cobra. Built by Alejandro Detomaso's small Italian operation, this exotic machine promised to deliver American V8 power wrapped in stunning Italian bodywork. Only 401 units would ever roll off the production line, with 150 destined for Europe and 251 for North America. What buyers received was arguably one of the most beautiful cars ever designed, standing just 43 inches tall, with breathtaking proportions that made it look like it was moving at standstill. Under that gorgeous exterior lived a modified P70 chassis, with the wheelbase stretched from 2390mm to 2500mm. The early European models packed Ford's high-performance 289 cubic-inch V8, producing 306 brake horsepower at 6,200 revolutions per minute and 411 pound-feet of torque at 3,500 revolutions per minute. Later production cars received the Ford 302 V8, making 271 brake horsepower, though this was the engine most buyers actually received. The power plant sat behind the driver, connected to a 5-speed ZF transaxle identical to the one used in early GT40S. At 1,185 kilograms dry weight, the Mangusta should have been a formidable performer, but there was a catastrophic problem lurking beneath the surface. The weight distribution was an absolutely disastrous 32% front and 68% rear, creating what automotive journalists would describe as inherently unpredictable handling characteristics. This extreme rear weight bias, combined with a less than rigid backbone chassis, created a perfect storm of instability. Automotive experts noted that chassis flex gave the car simultaneous understeer and oversteer. This wasn't just uncomfortable, it was genuinely dangerous. The combination of structural weakness and poor weight distribution meant the car could exhibit completely contradictory handling behaviors depending on the situation. Contemporary automotive reviews summed up the dilemma perfectly. There are other cars we would rather drive, but none we would rather be seen in. They noted the cramped driving position that put drivers almost on the floor while praising the stunning aesthetics. Other reviews described it as well-behaved, but could be dangerous if it wanted to be. Tellingly, testers avoided testing beyond 50 miles per hour due to the car's known handling issues. The real problems emerged at speed. The extreme rear weight bias caused high-speed instability that made fast, sweeping curves genuinely terrifying. The tail-happy characteristics were difficult to control, and the car developed what automotive experts described as concerning stability issues even when claiming a top speed of 250 kilometers per hour or 155 miles per hour. Contemporary road tests consistently criticized the car for being too hard to handle on the road. It was described as extremely difficult to live with as a day-to-day proposition, even in supercar terms. The quality control was poor at best, and some desperate owners even added chassis gussets to remedy what they called insane flexion issues. The Mangusta represented everything wrong with the exotic car philosophy of the 1960s. It was a machine where form triumphed completely over function, where aesthetic beauty masked serious engineering deficiencies. The car was chronically underdeveloped due to the rush to market, and it showed in every aspect of its dynamic behavior. Despite its flaws, the Mangusta became a cultural icon. It represented the pinnacle of Italian exotic car styling and became a cautionary tale about prioritizing aesthetics over engineering. The lessons learned from its failures directly influenced the development of its successor, the Pantera, which featured a completely different chassis design that addressed many of the Mangusta's fundamental problems. In 1981, Maserati made automotive history by introducing the world's first production car equipped with twin turbochargers. The Biturbo was designed to bring Italian prestige to the mass market, representing Maserati's desperate attempt at financial recovery. Initial sales were strong, with about 40,000 units sold, but the enthusiasm would prove short-lived as quality and reliability issues destroyed the car's reputation. The Biturbo's heart was an all-aluminum 90-degree V6 engine based on the Mark V6 design. The original 2.0-liter version produced between 177 and 202 horsepower, thanks to its twin turbochargers and 3 valves per cylinder design featuring 2 intake and 1 exhaust valve. A larger 2.5-liter version followed, generating 185 brake horsepower at 5,500 RPM and 208 pound-feet of torque at 3,200 RPM. Early cars used a single Weber carburetor, making the twin-turbo system particularly problematic until fuel injection arrived in 1987, boosting U.S. models to 187 horsepower. The suspension followed typical 1970s European design philosophy. McPherson struts with coil springs and an anti-roll bar handled the front, while the rear used semi-trailing arms with coil springs and an anti-roll bar. The differential and rear suspension were supported by a subframe, creating what should have been adequate handling dynamics. But the Biturbo's semi-trailing arm rear suspension was fundamentally flawed. This design, similar to problematic systems used by BMW and Ford Sierra, caused unwanted toe changes under acceleration. The result was snap-oversteer tendencies that made the car genuinely dangerous, especially under power. The rear suspension geometry created unpredictable handling transitions that could catch drivers completely off guard. The twin turbocharger system made everything worse. Severe turbo lag followed by violent power delivery created a Jekyll and Hyde personality that made cornering treacherous. The power delivery unpredictability meant that drivers never knew exactly when boost would arrive, and when it did, the sudden surge could overwhelm the rear suspension's ability to maintain control. The carbureted versions were particularly problematic, with lag and response issues that made smooth driving nearly impossible. Beyond the fundamental handling problems, the Biturbo suffered from catastrophic reliability issues that made it nearly undrivable. Chronic overheating plagued carbureted models, while turbocharger failures caused smoke and power loss. The complex twin-turbo system was prone to failure, and running lean conditions caused widespread reliability problems. Electrical issues affected every system, and poor quality control meant parts failed prematurely. Automotive critics ranked it among the worst cars ever made, with multiple publications placing it in their top 30 worst cars ever to be sold lists. Experts described it as hugely expensive to maintain and one of the least reliable cars ever made. Owners were warned it was guaranteed to leave you stranded on the roadside without a moment's notice. The quality was described as bad even by Italian standards. Parts availability was poor, with bottlenecks in sheet metal parts, windshields, rear brake discs, turbos, and shock absorbers. Maintenance and repair costs were astronomical, and workshop acceptance for repairs was limited worldwide. Maserati eventually recognized the problems and attempted fixes. Later models had some snap-oversteer tendencies tuned out with suspension modifications. The introduction of fuel injection in 1987 improved reliability somewhat, and power output increased to 187 horsepower. Subsequent generations showed some handling improvements, but the damage to the brand's reputation was already done. The Biturbo's cultural significance extends beyond its failures. It pioneered twin-turbo technology in production cars, representing Italian automotive ambition versus execution capability. It became a symbol of 1980s excess and poor quality control, with its reputation damage causing significant sales decline. The car influenced stricter quality control standards in luxury car manufacturing and served as an example of innovative technology undermined by poor execution. When the Austin-Healey 3000 was announced on July 1, 1959, it represented the pinnacle of classic British sports car design. This evolution of the Austin-Healey 106 came equipped with BMC's 3-liter C-Series engine and promised to deliver quintessential British roadster excitement. Despite its success in motorsport and its status as a cultural icon, the Big Heeley harbored fundamental handling flaws that made it challenging even for experienced drivers. The 3000 evolved through three main variants during its production run. The Mark I, produced from 1959 to 1961, featured a 2,912 cc BMCC series engine, producing 124 brake horsepower at 4,600 revolutions per minute and 162 pound-feet of torque at 2,700 revolutions per minute. The Mark II, built from 1961 to 1963, maintained the same displacement but increased output to 132 brake horsepower thanks to triple SU carburetors and a reworked camshaft. The final Mark III, produced from 1964 to 1967, pushed power to 150 brake horsepower at 5,250 revolutions per minute and 170 pound-feet of torque at 3,000 revolutions per minute. All variants used a standard 4-speed manual transmission with an optional Laycock de Normanville overdrive system that was widely praised by drivers. The suspension followed classic British sports car configuration with independent front suspension using coil springs and a solid live axle with semi-elliptic leaf springs at the rear. Anti-roll bars were available front and rear, though they were essential for managing the car's handling characteristics. The fundamental problem was weight distribution. The monstrously heavy engine up front created a severe front weight bias that led to chronic understeer problems. Contemporary reviews noted that handling was surprisingly good but did tend a bit too much to understeer. The heavy C-Series engine created a front-heavy balance that overwhelmed the front tires in spirited driving. The chassis design represented cost-cutting that compromised handling. The axle-over-frame design, except for the very last cars, was described as a stupid move to save money and compromised handling. This dated suspension setup used a flat frame rather than a kicked-up design over the rear axle, limiting rear suspension travel and affecting handling in racing situations. It wasn't until 1965 to 1968 that models finally altered the chassis to go over the axle with radius arms added. Contemporary automotive tests noted that the suspension provides a harder ride than many lighter and later sports cars. By 1963, there was much evidence of a 10-year-old design in the car's dynamics. However, experts praised the overdrive system as key to driving enjoyment, noting that in many ways the fun of driving a Heeley is directly traceable to this transmission. Expert driving assessments revealed the car's true character. Skilled drivers noted that, given sufficient practice and not a little nerve, it is possible to corner the Heeley very fast indeed. However, it was not the sort of car that you drive on the limit first time out. The car required a delicate touch on both the throttle and steering wheel, and either throttle or steering could be used to direct the car. Interestingly, some owners disputed the understeer claims. One owner of a 1966 Mark III stated, "Understeer was not something I ever remember with my 1966 Mark III." Rally drivers noted the importance of getting it set up for the corner and using oversteer to get round, suggesting that skilled drivers could overcome the design limitations through technique. The aftermarket recognized the problems and developed solutions. Anti-roll bar systems were developed to reduce understeer and control oversteer effectively, which transforms Big Heeley's handling, enabling the car's full potential to be realized. Competition preparation could overcome some handling limitations, allowing the car to excel in major rallies and circuit races. Despite its handling compromises, the Austin-Healey 3000 achieved remarkable motorsport success. When prepared correctly, the challenge of driving them in competition can put a huge smile on your face. This success demonstrated the car's potential when properly set up and driven by skilled hands. The Big Heeley's cultural significance extends far beyond its handling limitations. It represented the very epitome of the classic British sports car and became a symbol of British automotive engineering philosophy. It demonstrated the compromise between performance, cost, and practicality that defined the era. influencing the design of subsequent British sports cars while becoming a collector favorite despite its handling limitations. The Triumph GT6 Mark I arrived in July 1966 as the hard-top coupe version of the popular Spitfire Roadster. With its stunning fastback design by Giovanni Michelotti and its 1,998cc straight-six engine, it was marketed as the poor man's E-Type due to styling similarities with Jaguar's Icon. However, beneath that beautiful exterior lurked one of the most dangerous suspension designs ever fitted to a sports car. During its brief production run from July 1966 to September 1968, Triumph built 15,818 GT6 Mark I ES. The car featured a 1,998cc straight-six engine with a bore and stroke of 74.7 by 76 millimeters, a compression ratio of 9.5 to 1 for most markets, though U.S. models from 1968 used 8.5 to 1. Power output was 95 brake horsepower at 5,000 revolutions per minute with 117 pound-feet of torque at 3,000 revolutions per minute, connected to a standard 4-speed manual transmission with optional overdrive. The front suspension used conventional independent setup with coil springs, but the rear was where the problems began. Triumph inherited the swing axle system from the Herald Small Saloon, featuring independent swing axle suspension with a transverse leaf spring, trailing radius arm, and telescopic shocks. A single leaf spring was configured crosswise between both rear wheels, creating a system that automotive experts would later describe as fundamentally flawed. The swing axle design had been adequate for the Herald's modest 34.5 brake horsepower, but contemporary reviews noted that in the saloon it was tolerated, in the little Spitfire it was not liked, and in the powerful GT6 it was heavily criticized. Engineers at the time recognized that while the system was fine when it was designed, when you start upping the power to 95 brake horsepower, that's no longer the case. The GT6's handling problems manifested as sudden hard-in-mouth oversteer in fast, sweeping curves. The car had a dangerous tendency to break away if the driver lifted off the power mid-corner, a problem not helped at all by the increased weight at the front of the car. Contemporary drivers reported the car would swap ends if anyone so much as breathed a film of moisture onto the asphalt. The most frightening characteristic was the notorious jacking effect. Drivers described feeling most odd when the back of the car sits up and the thing starts to pivot on its axis. This rear suspension tuck-in issue caused dangerous handling transitions that could catch even experienced drivers off guard. The swing spring was later developed to avoid doing the Russian jig upon hard cornering, a telling description of the car's unpredictable behavior. The suspension geometry problems stemmed from the relative lack of weight on the rear and the high-ish pivot for the arm at wheel centerline. This created instability that was exacerbated by the swing axle geometry, causing extreme camber changes under cornering loads. The transverse leaf spring design was simply inadequate for handling the suspension loads generated by enthusiastic driving. Contemporary automotive reviews noted that breakaway was deemed to be smooth, resulting in a bit of oversteer that can be enjoyed and utilized by a moderately skilled driver while never crossing up an unskilled one. Testers found that for ordinary to brisk driving, the car steered neutrally and simply goes where it's steered with great apparent stability, and noted that the tail of the GT6 could be brought out at will, either with the throttle or by tweaking the steering wheel. However, other automotive assessments were more critical, stating that the transition from under to oversteer is abrupt and can catch a driver out, especially if a panic brake in mid-corner. Critics noted that most drivers resorted to flicking the car into a bend and using the throttle to make best use of the oversteer characteristic. Modern assessments are unequivocal about the problems. Lift-off oversteer was a very real problem as the wheels tucked under, and even today, it's only partially cured by the fitment of modern tires. Current experts warn that the first cars are the best looking, but they have the rudimentary suspension and the snap oversteer issue. Triumph eventually acknowledged the serious handling defects in the Mark I and responded with significant changes. The Mark II, introduced in 1969 as the GT6 Plus, featured Rotoflex rubber driveshaft couplings that significantly tamed the GT6's tendencies to break grip mid-corner. The rear suspension uprights were articulated between lower control arms and the leaf spring, providing better control over camber changes. The Mark III made further modifications, reverting to swing axle design but adding a swing spring that eliminated rear roll stiffness and prevented the outboard wheel from jacking under cornering loads, greatly reducing the jacking effect under cornering loads. Despite its road car issues, the GT6 found success in racing when properly prepared, with professional drivers able to manage the handling characteristics through skill and race-specific modifications. The successive generations showed Triumph's responsibility in addressing the problems, demonstrating the manufacturer's learning from dangerous design decisions. The GT6 Mark I became a symbol of the dangers of cost-cutting in sports car development and an example of how attractive styling could mask serious engineering flaws. Today, it remains popular with enthusiasts who understand its limitations, serving as a reminder of the importance of matching suspension design to power output. When Porsche introduced the 911 Turbo in 1975, they brought race-derived turbo technology to the road for the first time. Based on the 911 Carrera platform, this was Porsche's ambitious attempt to transfer racing innovation to street cars. What they created was a machine so dangerous that it earned the nickname the Widowmaker after several crashes and deaths were attributed to its handling characteristics. The original 3.0-liter version, produced from 1975 to 1977, featured a flat-six engine with a single KKKK turbocharger, producing 256 horsepower at 5,500 revolutions per minute and 329 newton-meters, or 243 pound-feet of torque at 4,000 revolutions per minute. The car weighed 2,641 pounds, though the 1975 model was lighter at 2,514 pounds. Because the regular 5-speed transmission couldn't handle the 255 pound-feet of torque, Porsche used a 4-speed manual instead. The 3.3-liter version, introduced in 1978 and produced until 1989, added an intercooler and increased power to 300 horsepower with 304 pound-feet of torque. U.S. models from 1986 onward, limited by emissions controls, produced 282 horsepower at 5,500 revolutions per minute and 377 newton-meters, or 278 pound-feet at 4,000 revolutions per minute. Despite the power differences, both versions achieved identical 0 to 60 miles per hour times of 4.9 seconds, according to contemporary testing. The 930's dimensions told the story of its aggressive stance: 168.94 inches long, 69.88 inches wide, 51.97 inches tall, with an 89.45-inch wheelbase. But it was the handling characteristics, not the specifications, that made this car legendary for all the wrong reasons. The Widowmaker reputation came from real-world consequences. Since this was the 1970s and safety features were virtually non-existent, many inexperienced owners ended up losing their lives to handling characteristics unfamiliar to drivers of the era. The combination of turbo lag followed by violent power delivery created a dangerous unpredictability that could catch even experienced drivers off guard. The original Porsche 911 Turbo had severe turbo lag, and the Borg-Warner KKKK turbocharger delivered power in what drivers described as a violent manner. Even the U.S. specification 930 turbos, which only made 245 horsepower, were tricky to drive. Hit the throttle mid-corner, and you were very likely to experience snap oversteer. The power delivery was compared to being kicked in the back by a donkey. The fundamental problem was that the race-derived flat-six engine overpowered the chassis. The road car's chassis wasn't meant to handle so much power, nor the way it was delivered. Under certain conditions, applying too much throttle would cause the heavy rear end of the car to swing outward like a pendulum, causing the car to spin out. The rear engine location created a significant polar moment of inertia that amplified these effects. Due to the weight transfer and the 911's rear engine layout, the rear had a tendency to try and overtake the front of the car upon lifting the throttle. This liftoff oversteer combined with the classic 911 rear engine dynamics was exacerbated by the turbo power characteristics, creating a perfect storm of unpredictable handling. Porsche's response to the danger was unprecedented. To this day, Porsche corporate employees who drive 911 turbo models for testing or business reasons are mandated to undergo turbo training. This requirement continues despite the fact that newer 911 turbo models are generally safer and easier to drive, demonstrating the lasting impact of the 930's reputation. Veteran drivers who experienced the 930 Turbo would advise never to go full throttle mid-corner because the turbo builds boost in a rather violent way. Expert assessments noted that despite Porsche's modifications, the car was prone to oversteer. However, those who knew what they were doing and managed to tame it fell in love with its rawness. Interestingly, some experts noted that the long gearing and turbo lag acted as a safety net, usually taking oversteer out of the equation by delaying the kick until the danger had passed. This unintended consequence meant that while the car was dangerous when boost arrived unexpectedly, careful drivers could use the lag to their advantage. The cornering dynamics were complex. The car would understeer at initial turn-in, transitioning to oversteer under power. The rear-engine weight distribution was amplified by turbo power delivery, requiring significant skill to manage safely at the limit. With limited safety equipment, typical of 1970s sports cars, and no modern stability control or traction management systems, driver skill and training were essential for safe operation. Despite its road car challenges, the 930 found success in racing applications with professional drivers who understood its characteristics. Race versions had modified suspension and safety equipment, demonstrating the gap between racing technology and road car application. Today, the Widowmaker reputation adds to its collectability. It's considered one of the most significant 911 variants, with values appreciating due to historical significance and rarity. Modern perspective views it as the last of the analog supercars, appreciated for its pure, unfiltered driving experience and respected for its demands on driver skill and attention. In 1960, General Motors launched the most controversial car in American automotive history. The Chevrolet Corvair represented a revolutionary departure from traditional American design, featuring a rear-mounted, air-cooled, flat-six engine that had never before, and has never since, been put into production by a major U.S. auto manufacturer. This bold attempt to compete with the Volkswagen Beetle and respond to the compact car trend would ultimately become the subject of the most famous automotive safety controversy ever. Designed under Ed Cole's leadership at Chevrolet, the Corvair was GM's answer to changing market conditions. The first generation, produced from 1960 to 1963, featured the Turbo Air 6 engine in various configurations. The standard 1960 to 1962 models used a 2,376 cc or 145 cubic inch flat six, producing 80 brake horsepower at 4,400 revolutions per minute. An optional RPO 649 Super Turbo Air version generated 95 horsepower at 4,800 revolutions per minute and 125 pound-feet of torque at 2,800 revolutions per minute. For 1963, Chevrolet expanded the options with the standard 80-horsepower 2,376 cubic centimeter engine, an optional 2,687 cubic centimeter or 164 cubic inch version producing 110 horsepower, and most dramatically, a turbocharged 2,376 cubic centimeter engine in the Monza Spider that generated 150 horsepower. The transmission options included a 3-speed manual standard with a 2-speed Power Glide automatic optional and a 4-speed manual introduced in 1961. The Corvair's construction was innovative for American cars, featuring an aluminum crankcase and cylinder heads with integrated intake manifolds. A centrifugal cooling blower provided 1,850 cubic feet per minute of airflow at 4,000 revolutions per minute, eliminating the need for a radiator and water jackets, saving significant weight. The car rode on a 108-inch wheelbase and measured 180 inches long, with pricing ranging from $1,990 to $2,800 in 1963. The handling problem stemmed from the swing axle suspension design used in the first models from 1960 to 1963. This system was prone to tuck under in certain circumstances, with independent rear wheels connected to the transaxle by single, non-articulating axles. This configuration could lead to significant camber changes during cornering or when the car encountered bumps. The dangerous oversteer characteristics manifested when the rear end approached or exceeded its limits. Centrifugal forces acting on the rear of the car caused the outside wheel to tuck under the body, resulting in the rear rising and drastically exacerbating the intrinsic oversteer of a rear-engined car. In aggressive turns, the rear end tended to lose traction before the front, causing oversteer or fishtailing. Most concerning was the rollover propensity. There was a chance, albeit slim, that the outside rear wheel could tuck in under the body and potentially trip the car into a rollover. The handling transitions were complex. The car understeered like conventional passenger cars up to about 0.4 g lateral acceleration, then made a transition from understeer through neutral steer to oversteer in a range from about 0.4 g to 0.5 g lateral acceleration. Critical to safe operation were the tire pressures, which required an unusually high front-to-rear pressure differential, 15 psi front and 26 psi rear when cold, or 18 psi, and 30 psi when hot. If tires were inflated equally, as was standard practice for all other cars at the time, the result was dangerous oversteer. Despite proper tire pressures being more critical than for contemporaneous designs, Chevrolet salespeople and Corvair owners were not properly advised of the requirement and risk. The controversy exploded in 1965 when automotive safety advocates raised concerns about the Corvair, calling it the one-car accident and claiming it was the most dangerous automobile on the road in the 1960s. Critics alleged that a design flaw in the rear suspension made the car likely to flip over when driven in abrupt maneuvers. These safety concerns were inspired by more than 100 lawsuits against General Motors regarding Corvair accidents. Investigation revealed cost-cutting decisions that may have contributed to the problems. Engineering recommendations for installing a stabilizer or anti-roll bar were reportedly overruled by GM management. A front roll bar, estimated to cost just $4, was originally intended to be used for its debatable effect in compensating oversteer to some degree. The impact on sales was devastating. Corvair sales halved in a single year, going from about 220,000 in 1965 to approximately 109,800 in 1966. The safety controversy effectively killed the Corvair's market acceptance and sparked a revolution in automotive safety regulation. However, the story has a complex ending. A 1972 government safety report disputed the allegations about abnormal handling in sharp turns, suggesting that the Corvair's rollover rate was comparable to similar cars. The review panel concluded that the 1960-63 Corvair compares favorably with contemporary vehicles used in the tests, and that the handling and stability performance does not result in an abnormal potential for loss of control or rollover, and it is at least as good as the performance of some contemporary vehicles, both foreign and domestic. By 1965, Corvair had introduced a completely redesigned rear suspension that eliminated the swing axle design problems. The new design was considered superior to many contemporary cars, but the improvements came too late to overcome the damaged reputation.